Let's suppose that we want to factor this trinomial. Whoa. I mean, look, it's got a coefficient. It's large. How in the world am I going to come up with the parentheses, the factoring that satisfies this trinomial? Well, I got good news for you. And it's not that you're not going to, but it's that we need, well, quite frankly, we need a little trick. Now, before we do the trick, first thing is just to recognize that there is a GCF. What you want to do is always keep that GCF idea sort of on the radar screen, because if I can take a 2 out of this, why wouldn't I? Why wouldn't I at least get some smaller numbers? Now I can I can do the business of factoring 8x squared, 6x, and minus 9. Well, it's still tricky. It's still tricky because I've got a coefficient. And a few days ago, we called that a trinomial, meaning that you have to try really hard to get that answer. Unless you have the British method. The British method, quite frankly, again, it's a little trick. It's a trick that we will use to basically come up with the numbers. We just have to, we have to follow the trick. Now, I would no way would expect you to know this, but I just want to show it to you, because sometimes the first time we see something, there's a lot of it looks new. Of course, it's going to look new, but the next time you see it, it won't be so new. So let's just take a look. These two red lines are implying that we need to multiply. We need to multiply 8x squared and negative 9. So that's what we'll do. Now, after you multiply them, you will bring down, without changing, you will bring down these outside terms. And here's where the real trick begins. You see, I need to come up with just the right pair of numbers. Just the right pair of numbers that do something, that multiply to be the triangle, but add to be the box. Kind of sound a little bit like how we were sort of dealing with these problems in a simpler day. Yeah, it's the same idea. We just want to come up with a pair of numbers that multiply to be the triangle, but add to be the box. Now, you still got to think. You still got to think to come up with those numbers. You have to think of numbers that multiply to be 72. If all you're thinking about is 9 and 8, there's no way to make 9 and 8 ever add to be 6. But may I suggest a 12 and a 6? Specifically, a positive 12x and a negative 6x. Notice that I put the x's with it. So what just happened here? Well, 12x and negative 6x, they multiply to be negative 72x squared, and they also add to be 6x. So why is this good? Well, it's good because now I can group. I can literally finish this problem with a grouping strategy. What's the grouping strategy? Well, it's what we just did yesterday, right? You're going to take out the greatest common factor of 8 and 12. You're going to take out the greatest amount of x, and we end up with 4x. Left over is a 2x plus 3. How about over here, the GCF of negative 6 and negative 9? Yeah, it's negative 3. And what are you left with? You're left with a 2x plus 3. Well, that's perfect because we always want these to be equal. We always want them to be the same. And all we have to do is just sort of copy down the GCFs, and then we will take the quantity 2x plus 3, which again was the same, and we will record that one time. And what did we just do? Well, we just factored, remember, that big crazy trinomial. How do we know that it's right? Well, you could check it. If you take 4x times 2x, you get 8x squared. I'm pretty sure that was part of the original trinomial. If I multiply here, I'll get 12x. If I multiply here, I'll get negative 6x. Look familiar? And then these last ones will multiply to be negative 9. Of course, 8x squared and 12x minus 6x is 6x, and then minus 9. So it's factored. With one little add-on, remember that 2 that we pulled out in the very beginning? It's still in front. It's still in front of my factors. So again, I'll carry that 2 down, and I end up with the factoring of the original mammoth trinomial. So it's called the British method. We'll call this topic 3.6, and I'm going to encourage you to use continue to use the back of that factoring paper. It's just a good place to kind of have it all in one spot. I'm going to give you the British method in symbols, not so much in words, but in symbols. Maybe you want to kind of squeeze that maybe in the middle down here. And then we're going to do some problems in both of the corners. So how do we do? Well, first of all, what is the British method used for? It's used for a trinomial, especially a trinomial that's got a leading coefficient, because when you have a leading coefficient, it gets harder, but it's doable when you have this trick. It's called the British method. Now remember, the first thing we did was we multiplied the outside terms. We multiply them together. By the way, I also put them in like a red triangle. And you can even put the bx in like a box if you want. But the first thing is that you multiply those outside numbers. You bring down the outside numbers. And then the real trick to this problem is, can you come up with b1x and b2x? Can you basically come up with the two terms? The two terms that multiply to be the triangle and add to be the box. That's the key to this problem. If you're going to get b1x and b2x, the two magic numbers, they have to multiply to be the triangle and add to be the box. And then don't forget to finish the problem by factoring with grouping, but you'll do a good job with that. Well, you'll do a good job with this whole thing. You just kind of have to get the hang of the little trick. So what's the first thing we do? That's right, we multiply the outside numbers. You can put a little triangle around them if you want to. And we can even get ready for a little box here. The outside numbers, they don't really change. You'll notice that they become part of the final answer just like they were. But I also add these two magic numbers that do what? That multiply to be the triangle, but add to be the box. How you doing? Are you already thinking of 8 and 3? Well, it's really 8x, and it's really 3x. But yeah, 8 and 3 are the magic numbers. Now, once you have those created, you're ready to finish the problem with grouping. And yeah, this is good news, because all you got to do with grouping is take out a GCF. After you take out that GCF, you're going to be left with, well, it looks like we'll be left with an x plus 4. And then we can do it again. We can take out a GCF. I hope you're going to take out a 3. And you'll be left with, well, look at that, the same thing. You'll be left with x plus 4. So remember, when you do factoring with grouping, you always record the two GCFs. They become like one of your factors. And then the factor that repeated, it becomes the other factor. Not too bad. Okay, as long as you, again, you kind of get the hang of the trick. Why do we call this the British method? Should I be teaching the lesson with like a British accent? I don't think so. It's because the diagram that we have over here is kind of like a British flag. A British flag has that sort of that X look to it. It's a little bit of a stretch, but you kind of have this these arrows that make it, well, look like a British flag. Hey, I didn't make it up, okay, but it works. Do you think you're ready to just try one? Sometimes students are. So if you're that student, push pause, give this thing a try. You're trying to factor, and you're using the British method. multiply them together. Even though there's the number 1 right there, multiply them together. Bring down your outside numbers along with the x's. Magic numbers. Multiply to be the triangle, add to be the box. What are you thinking? Numbers that multiply to be 9 and add to be 6? You got it. 3x and 3x. Now I really know I got it when I go to finish the problem and hopefully discover that, the grouping method works. Take out a GCF. That would be the highest number that goes into 9 and 3. There's also an x that's part of that. Now, I'm still left with a 3 and an x and a plus 1. Be careful, you're left with a plus 1. What's the GCF over here? Yeah, you're right, it's 1. There really isn't 1, but we call it 1 because I need to have something. I need to have 2 GCFs that I can record in a factor. So there we go, a 3x and a 1. And then, oh, you mean like another 3x and a 1? Yeah, you always write down that factor that showed up twice. Now remember what's going on here. What's going on? You are factoring. You're factoring the original problem. The original problem, which was 9x squared plus 3x plus another 3x. That's going to be 6x. And then finally plus 1. This is what I started with, right? Well, that's good because I came up with the factors 3x plus 1 and 3x plus 1. Well, guess what? Now that we have this British method, we can factor some tougher problems. And the other thing is that you want to not forget the old factoring. For example, looking at these 3 terms and saying, wait a minute, they all share a common GCF. I keep going back to this GCF idea because it's important. If there's a GCF in a problem, you always want to take it out first. Now, when I take out the x, that's actually the best GCF that I can take out. I'm left with a negative 12x squared. Listen, usually we don't like to have a negative leading coefficient. It just makes the problem harder. So how can I remedy that? Well, I can take out a negative x. There's nothing wrong with taking out negative x. In fact, it actually takes care of all this negativeness, that was in my trinomial. So something to think about. Now I have a positive 12x squared, and it turns out that everything else is positive too, which is nice. Now listen, you're going to do the British method on the trinomial, but don't forget about this negative x that we took out. It'll still become part of our final answer. Multiply those together, right? Bring down the 12x squared, bring down the 6, the 10, and, I got to try to find numbers that multiply to be 120, but add to be 23. Okay. Sometimes, you just got to get going on your calculator. Could I give you a problem like this? I could. We're doing it right now. Listen, it turns out that 15 and 8, that is 15x and 8x, they actually do multiply to be 120, and they definitely add to be 23. So we got it. And we especially know we got it when we finish the problem with grouping. Now, make sure you take out a 3x. Okay, that's the GCF, leaves you with a 4x and a 5. And then over here, I can take out a 2. That's the highest number that divides into 8 and 10. And look, it leaves me with a 4x plus 5. That's the way this is supposed to work. That way you know you're right. Put the GCFs as a factor and record 4x plus 5. Hey, what about this negative x that we pulled out up here? Yep, that's still part of my final answer. You see, in this problem, I end up with 3 factors. I get a negative x, I get a 3x plus 2, and a 4x plus 5. Let's do one more for a couple reasons. First of all, remember, first thing you want to be thinking is GCF. When you see x cubed, x squared, and x, you got to say, all right, I can take out that x. I need to take out that x so that these things can sort of get smaller. Honestly, I haven't really said this, but also so that we have an x squared. You have to have an x squared to be able to use this method. But you know what? Instead of using that method, I'm going to try to just kind of go back to the trinomial method. What's the trinomial method? Well, listen, sometimes all you really got to do is just, come up with the correct numbers. And the thing about this problem is, if you think about it, there's only a 7x and an x. It's going to multiply to be 7x squared. So there's not too many options there. And then look, if you look at this negative 2 out here, I'm pretty sure there's only 2 numbers that multiply to be negative 2. They're going to involve 2 and 1. Now, remember how this worked a few days ago? We basically had to just put 2 and 1 in the right order. Like, does it go this way, 2 and 1? How do I know? Well, I just got to do a quick little check, sort of that forehead and smiley face. Now, that's going to give me like a 7x and a 2x. Is there any way for a 7x and a 2x to be 13, or that is negative 13x? No. Does that mean I'm wrong? No, it just means that it should work if I put the 2 and the 1 this way. Are you able to kind of see this in your head? This is going to give me 14x. Hey, that's pretty close to 13x. It's 1 away. Actually, it's negative 13x, so I need the 14 to be negative. That is, I need the 2 to be negative. By the way, the 1 then would be positive. So what am I doing here? Well, I'm kind of skipping or not using the British method because, maybe I don't have to. I don't have to if I am able to, do a little bit of guess and check, I guess you can call it. But it's basically just being smart about what kinds of numbers multiply to be 7x squared, and then checking them to multiply to be negative 2 and add to be negative 13. And so we're done. Okay, I factored it. And again, no British method officially needed. All right, well, you're ready for the homework helper. You should be able to find that homework helper where it always is on the calendar under today's lesson.